All right, so today we are taking a look at how to solve something that looks like this, solving an exponential equation. The key thing here, of course, is noticing that it is exponential. That is, the x is in the exponent. And so we have to have a way to be able to solve for an exponent. Now, earlier, a week or two ago, we learned that there actually is a particular tool, an actual function type that is used to solve for exponents. What is that? Log, yeah, the logarithms. And so my technique for solving an exponential is to use the logarithm. So I rewrite the exponential into logarithmic form. And so in this case, that becomes x equals log base 8 of 80. Side note here, if you wrote it as log base 8 of 80 equals x, that's also perfectly fine. It doesn't matter which side the x is written on. I just wrote it first as a matter of course because I'm trying to figure out what x equals. All right, now we actually need to calculate this value, and now we also know how to do that using change of base formula. And so to actually calculate this value, then, we're going to have to do log of 80 divided by log of 8. Remember, the base always goes on the bottom. I remember it that way. I actually just remember the phrase, the base goes on the bottom, but some of you might also remember it because the base is written lower, and notice when we write in the fraction, it's also written lower. Same thing. Now, when we then go and solve it, we go ahead and do that calculation. We do log of 80. We divide it by the log of 8, and we get an answer of about 2.11, and we're done. That's your final answer. That's what we are after here. Notice it is a wavy equal sign here because it's approximately equal to 2.11. These are going to generally be a lot of decimals, and so just showing that it was rounded by putting in the wavy equal signs. It's not a critical thing for our work here. It's not a big point of emphasis, but it is something you should be aware of as we go. So having done that last problem, we've seen the basic strategy. You should now be able to tackle something like this. But of course, this is much bigger and much more complicated. I want you to start by writing it down, of course, but then start thinking about what's the first thing you're going to do. And then what will you do after that? Start actually working through the process so we can see how far can you get before questions start arising. Now, as you take a look at this and are strategizing, the 3 to the power of x minus 1 is basically going to be our end goal to isolate. Once I've done that, then I'm going to be able to actually use some of my fancier techniques. But I got to get that by itself first. So notice what's in the way is the times 2 and the minus 8. So I want to deal with those first. And the first one I always like to get rid of is any addition or subtraction. And so I'm going to go ahead and add 8 to both. Now, thinking about, we got to get rid of the addition and subtraction first. You might be thinking, okay, well then should I move the 1 over, undo that minus 1? It'd be nice if we could, but we can't, because the minus 1 is trapped in the exponent. And so this is actually all we can do in terms of the addition and subtraction at the moment. All right, now I can go ahead and deal with the 2, because remember I'm still trying to get 3 to the power of x minus 1, this part by itself. So I'm going to want to divide both sides by 2 to get that far. Now notice what we did is we basically isolated the exponential part of the equation. This is what we have to do before we turn into a logarithm, but once we've gotten here, I can now go ahead and do that. I can now go ahead and turn this into a logarithm. So before I show you what it looks like, if you haven't yet, rewrite this expression, please, as a logarithm. So when we go and write it as a logarithm, of course, the base is always whatever is raised to the power, so it's going to be log base 3 of whatever is by itself in the exponential form, so that's going to be the 64. But the question is, what does it equal? Remember, log always equals the exponent. My exponent here is not just x, though. My exponent here is the whole x minus 1. And so when I say, what is the exponent, it's got to be that whole. And so it's going to be x minus 1 equal to log base 3 of 64. And once again, if you put the x minus 1 on the right side instead of on the left side like I did it here, that's perfectly fine. It doesn't matter. I just am in a habit of writing my x on the left side when I'm solving these, so it looks a little pretty at the end. And so in order to figure that out, the first thing I'm going to do is actually figure out the value of log base 3 of 64. So that means I'm going to go ahead and use the change of base formula. So I'm going to do log 64 divided by log 3. And that gives me about 3.78. Now, this is a little thing I've always done that helps me keep track of all this stuff. It's a nice technique, I think. Notice I wrote 3.78, and then I wrote the 3 dots afterwards. So I'm showing it's 3.78, and the decimal just keeps on going after that. I'm not writing down the whole thing. I'm going to keep the whole thing, though, up on my calculator. You don't clear your calculator and retype 3.78 back in, or you could give yourself some rounding error, depending on how it's all going from there. All right, so now that I have this, I still need to figure out what x is. Of course, there's only one thing left to do, right? I got to get rid of that minus 1, and I can do that since it's not in the exponent anymore. So I add the 1 to both sides, and I end up getting x is about 4.79. Now you'll notice, when I wrote it up here earlier, it was 7.8. Adding the 1 didn't change that 8 to a 9. It was just that I was just writing down the first few digits of my decimal. I wasn't actually doing the rounding at that point. When I added the 1 on my calculator, I still had 3.78 numbers, numbers, numbers. Then I just pressed plus 1 equals, and since that was my final answer, that's when I rounded it. I only wait to round until the very end. Especially now that we're dealing with logarithms, because you probably notice when you do some of these logarithms in your calculator, like log 3, it gives you these really small decimals, right? When you have a really small decimal, 1 little thousandth in such a small decimal, when you multiply or divide by it, can be huge differences after actually doing that multiplication or division with it. So you always want to be using exact decimals, or it's going to cause you problems. So because this is going up by a given percent each year, remember that's the critical thing there. If it's going up by a certain percent every single year, then we know that this is going to be that compounding interest formula. A of t equals p times 1 plus r to the t. And when you plug that stuff in, you get this. A of t should equal 150 times 1.04 to the t. But I've not put in all of our information in this case yet, right? Normally, up to this point, I've always given you the value of t. We've always known what the number of years is. But of course, that's what this one's looking for, because it's asking us, how long will it take? In other words, what's the value of t that will give us this, the 350? Now the 350, that's our final value. That's the amount after t years. So I'm going to take that 350, and it's going to be plugging in over here. Now one thing we got to look at though with this, because I've seen a number of people do the same mistake on this, because we forget the way function notation works. And so we got to be really clear here. Remember what this means. This does not mean a times t. This is the value of a at t. It is all one value. And so a of t here is going to be the 350. There's no more t over there. Yes, I know, we're still going to have t here. And so we're going to have an equation that's looking like this. But notice there's not a t on the left-hand side. That's because a of t, again, is one value. That's not two values written next to each other. It's all one value. That's our function notation there. So just don't get yourself caught off guard with that. All right, so to solve this out, remember the first thing we want to do is get all the exponential part by itself first. So the exponential part is the base and its exponent. In this case, 1.04 to the power of t. I want to get that by itself, which means I want to get rid of the 150 first. And so I divide both sides by 150. Now, on your paper, I wrote it here. You'll notice it's 2.3 repeating. I put the bar over the 3. You didn't have to do that on your paper because it's just for your tracking what these numbers are giving us. You might have written 2.33 and then maybe the 3 dots after. That would be fine. Why didn't I do it this time? Because that was more writing, and mathematicians are lazy. If we can find a way to cut a corner, we do. So it was easier to write a little line over the 3. Plus, it has the advantage of actually being the exact number, which is always a perk. So I got 2.3 repeating equals 1.04 to the t. I then am going to solve for the exponent. Therefore, if we're going to solve for the exponent, I have to write it in log form. That's why logarithms exist, remember, is in order to solve for the exponent. And so I write it in log form. And at this point, some of you are looking at it and thinking, like, that's some ugly looking stuff. Yeah, but you know what to do with it, right? You still know how to calculate it. Yes, there's decimals in it, but we still can calculate this value using change of base form. We can do the log of the 2.3 repeating divided by log of 1.04. That's fine. And a little note about this, and being really precise in our calculators. Where did you actually need your calculator as you're doing this? The first thing you did on your calculator is you divided by 150. So you did the 350 divided by 150, and it gave you this number. After that, everything else that you see there was just paperwork that we had done so far. It was just rewriting in a different form. So unless we press clear on our calculator, it's still displaying 2.3 repeating. Don't press clear unless you actually have to put in a different number, because it'd be kind of silly to press clear and then retype in 2.33333. It's already there. You don't have to type it in again. Especially because on your calculator, that's the first number you use when doing this. If you're doing this on a scientific calculator, the first thing you do is you do 2.3 repeating and you press log. And then you say divide, 1.04, press log, equals to do the division. Now, that's on a scientific calculator. If it's on a graphing calculator, you have that 2.3 repeating showing on there. The best tool that you can know how to use to help yourself out on one of those graphing calculators is the answer key, ANS. Second equals. Sorry, second negative is the answer. You see it's in ANS is written in yellow right above that negative key. Whenever you press that button and it shows on your calculator screen ANS, what it really means is it will automatically fill in whatever the last number it calculated was. So like if you have that 2.3 repeating up on your screen, you press the ANS key, it's plugging in that whole 2.3 repeating. So like you would type in to do this calculation on one of those, log, answer, end the parentheses, divide by log of 1.04. When you do that calculation, we should get an answer here of 21.60. And, you know, if we're going to round this to the nearest year, let's call that 22 years. Now, note, though, the level of precision and what it does here. Some people are inclined to just go ahead and round that to be a 2.3 instead of using the whole 2.3 repeating. If you did that, if you used 2.3 in this calculation instead of using all the decimals, it would give you an answer of 21.24. That's pretty close to 21.60 in this case, yes. But when we talk about how many years is that, what's the closest number of years that would be? Well, that would change things, because that looks a lot more like 21 to me than it does 22. And so you'd end up actually off by a full year with that little bit of rounding error in the calculator. So it's really something to look out for and really get to know how to do those exact calculations. And if you continue to have any trouble with it or anything, of course, let me know as we're working on these kinds of problems, because I can help you out, make sure you know the process, how to do that right.